to hear. All right, here we go. I told you we're going to be doing three-dimensional shapes now. If you want to impress somebody at the cafeteria table today, home at dinner, whatever, they're called polyhedrons. All right, polyhedrons. Those are the three-dimensional figures. So this unit, prisms, cylinders, pyramids. Anybody know what else? Pyramids, cones, and a circle as a 3D object, which we call a sphere. You guys are good. Yep. A sphere. Yep. Okay, those are called polyhedrons. Now, on every polyhedron, there are faces. Let's talk about those first. Faces, those are the sides. So everyone take a look at my cube right here. How many faces does that cube have? If you count it, they have 6 faces. Perfect. So I'm just going to say F equals 6 for faces. 6 faces. Edges. Those are the segments that make up the face. So take your time right now. Don't count a edge twice. You don't need to. How many edges are on that cube right now? How many edges now? Take your time. How many edges? A bunch. How many edges? 12. Nice job. And finally, there are vertices, which you're familiar with two-dimensional figures. Vertice for a three-dimensional, that's where the segments meet. Those are the endpoints of the segments. Okay, so if you want to go around and find how many vertices there are, we'll check it with each other. Anybody think they got how many vertices there are? 8. Everyone in agreement? 8. Okay, now, I think we could all agree it'd be pretty common maybe if you missed one, if you counted something twice. We had this mathematician way back in the day called Leonard Euler. Little history lesson, Leonard Euler. He did this a bunch of times because I guess he had some free time on his hands back in the 1800s. And he noticed a pattern with the number of faces, edges, and vertices. So here, I'm going to give it to you. And if you ever just want to check yourself, because again, you could count something twice or forget something as well. Here's what he figured out. Faces plus vertices minus edges. I don't care what the polyhedron is, always equals 2. Always equals 2. No matter what the figure is. Is that true for the one we just did? Faces, what's the faces plus the vertices? 14 minus the edges? 2. Always 2. You and your group right now, go ahead. Pyramid, triangular prism. Go right ahead. I'll give you about 2 minutes right now. And make sure your answers fall into his little check. All right, so how many faces, vertices, and edges for those two figures now? Oh boy, I didn't even have, look at that, unprepared. Didn't even have the old organizer set up. You think you can do this without? Nope. Nope. Is it getting annoying? Good. Welcome to my world. 19? Okay, here we go. You're up for the pyramid, Dylan. Let's roll. Don't screw it up. Nice job. Good job not screwing it up. I like it. 3. How about this triangular prism right here, which we'll find some stuff for today as well. Look at this, 8, and I don't even have one. And look at you guys, huh? Don't even put 8, 7, and 8 there anymore. You're like, we don't care. All right, good. 91? No. Okay. 79? Good. 30? No. Yep, we're going to get it as annoying as possible. 72? 50? 39? Got all day. 86? 70? 11? There we go, Fiona. 1 out of 100 chance. There you go. What do you got for me here with this triangular prism? Yep. Nice job. Okay, everybody good? We can find edges, faces, and vertices. No issues? Next thing, I want to cut these figures now. I want to cut them. All right, and form what's called a cross section. All right, here we go. A little live action right now for you. Okay, so here it is. Here's a cylinder. Everyone's familiar with the cylinder. Think of a sheet of paper, whatever this is here. Think of it. I'm going to cut it parallel to the base right here. I hold it up to you. What figure is on that sheet of paper? A circle. That's a cross section. All right, is when I cut a three-dimensional figure, and I look at, and I turn it upside down here so I can look at it, what shape does it form? That's the cross section. Now, hey, is this the only way I can cut it like this, horizontally? No, I could also cut it vertically. Now watch what happens when I cut a cylinder vertically. Think in your mind right now what shape is going to be formed. Don't say a word. When I cut it vertically, perpendicular to the base, and I open it up and show you. Is it still going to be a circle? Some people are saying yes, some people saying no. Let's find out. Let's cut it. Oh, there we go. Cut it vertically. What happens? It's a rectangle. Okay? And that's also a cross section of a cylinder. It all depends on how you cut it. All right? We cut it horizontally. It was a circle. We cut it vertically. It was a rectangle. Good there. Oh, I'm not done. Wake it up here. Where do I want to go? Prisms. Rectangle. If I cut it horizontally. What do you think if I cut it vertically? Still a rectangle? Yep. So, and do you think anywhere I cut it, though, it would be a rectangle? Or could I get another shape out of here? What do you think? Do you think I could get another shape out of here if I cut it somewhere else? Any ideas? Any other shapes? How could I get a triangle? And this is what I'm trying to do here now. It was working early. If I just cut it here, I'm going to form a triangle, and I'm trying my best here, guys, to show you that I form a triangle. I want you to... Nope. I'm trying to get it. Well, almost. Well, that's not going to be a rectangle. That almost looks like a trapezoid. Oh, hi, look at me now. What did I just form here? Cutting it, almost slicing it off here. Now it's a triangle. Okay? So I can form it's not always going to be a rectangle or a circle. Okay? So let's answer a couple quick questions on here. So I have next page. Go ahead, next page. Which figure can have the same cross section as a sphere? So let's think of a sphere real quick. We'll put it up on the board. Spheres, spheres. There they are. Okay, there's my sphere. Really, no matter which way I cut it, it's always going to form a what? The cross section. It's always going to form a circle. So what I'm asking is, which one of these can I cut any way and still get a circle from? And that would be my what up here? My cone. Yep. If I cut it how? Horizontally, I would get a circle. Yes. Are we okay on these cross sections? Because you got about 5 of them tonight for the homework. All right, on your own right now. Think about it. I got a cone now. Which one will never be a cross section of a cone? Don't copy somebody next to you. Which one will never be a cross section of a cone? think we got a choice here. 24. Can never get a square. Here you go. Here's the cone, everybody. Oh, right there, what do I have automatically? Circle. Well, everyone see that one? And our multiple choice, the little arch. And then if I go vertically, what do I have? A triangle. Okay, so all three there I could see. I'm never going to see a rectangle or a square there. Nice job, Nam. Way to go, stud. Everyone all right with cross sections? All right, now here comes to the meat of the unit, is the lateral and surface area. Have we ever even heard of these terms? Yes, no, lateral, surface area? Yes, no, maybe? Okay, here's the deal. Every prism will have two bases, only two. All right, those are the ones that are across from each other. They're congruent and they're parallel. Basically, they're the same shape. So look at my prism up here. Anybody tell me the shape of the two bases? Because they're not rectangles. They're what? Oh boy, can we count the number of sides? They are pentagons, all right? So I want you to first be able to identify what the bases are. Those are the two figures that are parallel and congruent to each other. In this case, it's a pentagon, all right? Lateral area. Ready? I'm going to try to describe this best I can. If I fail, tell me. All right, I'll try some other way. Lateral area. That, and we'll write it down in a second. Take off the bases. Ready? Take off the bases. Find the area of everything that's left. All right, find the area of everything that's left. See what I mean? So if I wanted to find the lateral area of this prism right here, take off the pentagons, and what do you have left? Find the area of all the rectangles and add them up. Okay? Everyone good? So I'm going to put here, this is the sum of all faces. We're going to a little rhyme time now. Sum of all the faces except the bases. So take off the bases, find the area of everything that's left over. And then you go to surface area. Wild guess what surface area is going to be. Everything. Put the bases back on. That's the sum of all the faces. The entire figure. Everything that is showing on the outside. We okay? Lateral versus surface area. Yes? Lateral versus surface area. Oh, where'd it go? Oh, there it is. I don't know. What do you think? Do I go this? Or do I go this? Because we got some people nodding off. What do we think? The bell? The siren? Siren. Some of you get used to that sound. All right. Siren? Anyone pick that up? Okay, you got it. All right, because we had some nappers here. Not going to happen today. Not going to happen. Everyone all good? Lateral versus surface area. All right, let's try it out then. Come on. Oh, there we go. All right, let's try it out. You're going to find the lateral and the surface area of each. If we need to, we're going to round to the nearest whole number. All right, here we go. Rectangular prism. Rectangular prism. First thing I need to establish here, before we find the lateral area, is what's the basis? Because we can make an argument, well, if I tipped it, it's got new bases, right? Right? So it's got, you got the top and the bottom. But if I tip this thing 90 degrees, it's got a new top and bottom, right? So here's the rule we're going to follow when it comes to a rectangular prism. The bases will be the top and the bottom as it's drawn. Okay? As it's drawn, the bases will be the top and the bottom. Okay, good. How many faces total does it have? 6. Take out the top and the bottom right now, and I need your help finding what's left. All right, so what we're going to find right now, ready? Here's one face that's left. It's what by what? It's 10 by 3, and we know the area of a rectangle is length times width. And isn't there one in the back too of it? So I'm just going to multiply this by 2 plus, what am I still missing? These two right here, right? On the sides, these two. And they're what dimension? 3 by 3, and how many of them are there? 2 of them. So 2 times 3 by 3. Is everyone all right there? That lateral area. Don't add in the bases yet. That's not lateral area. So the lateral area, what do you got for me? 20. What do we have? And oh, wow. I didn't even have to prod it out of you. What was it? 78 inches. And yeah, lateral area. So yeah, the units are still squared. Nice job. Now go surface area. Most of your work is done. Why? You already know that 78's there. Now we're going to add in the bases, which are, what's the dimensions of the bases? 10 by 3, and how many of them are there? 2 that are congruent. So my surface area, 138 square inches still, surface area. All good. Anything you want to ask right now? What type of prism is this one? Triangular, meaning the bases are the triangle. So visually right now, take them off. Before we do lateral area, take off those triangles right now before we find the lateral area. How many faces do we have to add up here to find the lateral area? 3. Let's do the bottom one first here. What's the dimensions of the rectangle that's on the bottom? 12 by 16. Nice. How about the one over to the left-hand side? If you want to take a look, the one I'm tracing right here. 9 by 16. So plus 9 by 16. The only one we have not found is this one right here over the right that I'm highlighting in yellow right now. That's what? 16 by... It's not there. It's not there. You guys have more than enough ability right now. We're at the last unit right now. You have more than enough ability to find that other side. How? Pythagorean Theorem. So I got to do 9 squared plus 12 squared equals c squared. It's 16 by something. What's that other side there? Help me out. 8. What's the other side? Why do I keep doing this? Because I'm on fire here. 1, Maddie. 15. Yep. So the lateral area, you guys calculating it, 576 square inches. All right, now let's see who's on top of our game right now when we go surface area. Any issues with the lateral area? 576. Okay, surface area. We already know it's going to be 576 plus the 2 bases. What shape are the bases? From last unit. What's the area formula? Okay, so ready? Watch. Stop me if you don't know where it's coming from. 2 bases that are the same times 1/2. Give me the base of one of them. 12 times the height. Everyone all right with what I just wrote there? That's for the 2 bases. 2 bases that are congruent. The area formula for the triangle, 1/2 base times height.
Do you need to write the 2 times
You do not. No, if it's a triangle only. If it's a different shape, we got different issues. All right, but if it's a triangle, no, because they cancel each other out. Good observation. So as you guys crunch those numbers, what's my surface area? 13, what's the surface area when you're ready? Yep, thank you. And hey, real quick, and I call this a common sense thing. What should you always know about the surface area versus the lateral area? Yeah, it should be bigger. All right, surface area should always be bigger. If it's not, something is wrong. What? What type of triangle is it? Oh, why? Because they're the only two that are parallel and congruent. None of the rectangles are parallel, right? Because they always intersect. And any prism knob, the bases are always parallel to each other on opposite sides. Good? Okay. And the other one we got to talk about is a cylinder, a circular prism. Okay, a cylinder. I'm going to have a formula for you. Lateral area is still what? Everything but the what? Everything but the bases. All right. Ready to go. Here's my cylinder. Took off the bases. Here's what's left. What's left when I unfold it? A rectangle, which is length times width. But that's not going to be my lateral area I'm going to write down. I want you to get more specific for me. Ready? There's my cylinder again. How can you express, what's this of the cylinder right here? That's the height. All right, here we go. So it's going to be height, something with height. Something with height. Now you're going to have to go really hardcore here. Ready? This was the height, right? Ready? This part right here. Nice. That's the circumference, isn't it, of the circle? Formula for circumference from 2 units ago. There we go. You guys just found the lateral area of a cylinder is pi dh. Pi dh. Diameter times the height. And you know what? I don't think I should have to tell you the surface area now. What are you doing to find the surface area? You're taking the lateral area we just have. And what are you guys adding on to it? The bases, which are what? How many of them are there? 2 circles, formula from last unit. There you go. So cylinder, lateral area, pi dh, surface area, add on the circles. Yeah, Billy. No. The pi's only cancel out if they're on opposite sides of the equal sign. Good try. Somebody tell you to say that? Okay. You see what I mean? There's got to be a pi on this side to cancel something out. All right, here we go. Find the lateral area to the nearest tenth. These will go pretty quickly, and then we have a huge, big dog question to end this class. All right, lateral area of the cylinder, pi dh. I'm just going to need somebody. 5. Hi, Fiona. You got the diameter here, which is 10. All right, now let me just slow down because I know, okay, the height's 2 because it's the other number. I want you to, hey, stop what you're doing, please. I want you to realize where the height is on a cylinder because this could be drawn here, like this, who knows? The height, ready, of a cylinder is the distance between the 2 circles. Okay? Find the distance between the 2 circles, that's your height. Everyone see what I mean here? They're telling me 2 here. That's the distance between the 2 circles. Not just because it's the remaining number. All right, the height will be the distance between the 2 circles. And you guys can go ahead and round that one. And what are we looking at? 11, what are we looking at? 60. I have no idea if that's correct or not. Yes? No, it's not. There you go. What, Jack? You all right? Great. Great. You guys all right? The goof troop all right without the third member today? Okay. The actual probably leader, the goofiest of the three. Okay, next one, pi dh still for lateral area. Pi, just want to know what you're filling in for diameter here. 25 diameter. There he is. We just talked about him. Came back to bite me. 12 diameter. Are we on the same thing here? No, we're not. 6, and how about the height? Also 6, yes. Lateral area, nearest 10th. What are we rocking with here? 27. I don't know, is that right? Okay. Thanks. And then now let's go surface area. Hey, what are the directions here? Terms of pi, so we should all have a pi in our answer. So let's see how far we can take this sucker. Pi dh plus the two bases, 2 pi r squared. All right, I just need somebody to fill it in for me. 11, fill that sucker. You're on fire today if you want. Fill it in. Pi diameter, 2. Height, 3. Plus 2 pi radius, 1 squared. Remember, leave it in terms of pi. Don't punch that pi button on the calc. So I got 6 pi here, plus, what about on the right side? 6 pi plus 1 squared times 2. Can you combine these? Do they both have a pi in it? Yeah. So my final answer here is going to be 8 pi, thank you, meters squared. You're on your own for 6. You're on your own for 6. I'll ask somebody, not give you too much time because we got to get fired up for this last one. You're up, Fiona. Ready? Pi diameter, height, plus 2 pi radius, 3.5 squared. All right, so it looks like I get a 70 pi here, plus, not too sure. 24.5 pi, yep. So my final answer in terms of pi. Look at that. Nice job. Okay. Everyone all right? Because we're about to rattle some cages right now. All right? You better take a deep, deep, deep breath right now. Okay? Look at that, huh? This is how we're going to end every class, too, for this unit, is one of these. A figure on top of another figure. Last unit, we called them composite figures. When I shoved 2 together, now these are called composite solids, all right, because they're solids now. We're asking for the surface area, which today meant everything to us, right? Let's get a more detailed definition. Yes, everything, but everything that's showing on the outside. Let me say that again. Surface area, everything that's showing on the outside. Guys, this is not going to be as easy as find the cylinder, find the cube, add them together, we're done. It's not going to be that. Because ready? For the cube, is everything showing? Is everything showing on the cube? No, you got that little part that's covered up, right? Is everything showing on the cylinder? You got a base that's covered up, right? Okay. Surface area, everything that is showing on the outside. What do you want to do first, the cube or the cylinder? Sorry, too late. Cube, here we go. How many faces on the cube? How many faces on the cube? Total faces? Everyone, I got 6, right? So the surface area for the cube is going to be 6. What are all the dimensions are the same. What's one dimension of one face? 5 by? That's the entire cube right there. Everyone agrees? That's the entire cube. Stop. Everyone in agreement. That's the entire cube. But we just said the entire cube is not showing. There's a part that's covered up. So what we need to do is subtract out that part that's covered up. What shape is the part that's covered up, Caleb? Oh, go ahead. You got to. But the lateral area of the cylinder would be this part too? Okay. Yeah, that's fine. Yep, that's fine. Go ahead. See if we go ahead. Hey, I want you to do it that way now. See if we get the same answer at the end. Thank you. Okay. So back here, all right, we'll see if we match up in a second, Caleb. So I got the surface area of the whole cube. Now I got to subtract out that circle, though, because it's being covered up. What's the area formula for a circle? Pi r. So it's going to be pi. What's the radius of that circle? Oh, boy. Radius of that circle. 2 squared. Guys, look at that right now. Is everyone all right what we're doing with the cube? The whole cube minus the part that's covered up, which is a circle. So we're looking at, oh boy, anybody got 30? 150 minus 4 pi? And then we're not ready to round, so if you want to write that whole decimal, you can. You can leave it till the end. It's up to you. And what I'm getting about 112.5 decimal wise. Yes, no? No? Oh boy. One job. Sorry. 150 minus 4 pi. 130. There you go. Thank you, everybody. 137.4336294. Okay, so that's the part of the cube that's showing. Now let's go to the cylinder. How can you express to me what the cylinder is showing? Basically, the what is still there. This part right here, what do we call that? The whole lateral area is there. But now I won't add on 2 bases. What's showing? Just 1 circle. All right, the lateral area plus 1 circle instead of 2 because this other base is being covered up by the cube. All right, lateral area formula again. Pi dh. And I know I'm stringing this out. You guys can certainly just plug in your numbers now. All right, what do you got for me? Pi diameter, 4. What's the height of that cylinder? Distance between the bases is 4. Plus pi, I already asked this question earlier. The radius is 2 squared. So we end up with what? 16 pi plus 4 pi. And we're looking at, correct me if I'm wrong here, 62.83185307. And then what am I going to do with everything at the end? Add it up. Total surface area, here you go. And we get about, what are we rounding to? It doesn't say, does it? It looks like we're writing it all out, huh? 200.2654825 units, inches squared. I'm telling you this tonight. Do not just skip over this one on the homework tonight, because you're going to have another one tonight with a cylinder and a cube. All right, do not skip over it. Try it out. Try it out. Coming over, Remy.